The southwest region, Kingdom of Saudi Arabia, has experienced tremendous growth of population, industry, tourism and general population dwelling. Only the population growth is estimated to be around 6% in the region. This has caused a severe shortage of power and water in this area. To overcome the severe shortage, new facilities for water and power were being executed to facilitate the region. The Sqwec Water and Electricity Company, or Sqwec, was established by the Royal Decree No. 45, dated 01/02/1428, to fulfill the gap of shortage of water and electricity in the area. The Kingdom's legal reforms have set the framework for an ambitious privatisation programme that allows private investors to develop a number of independent water and power plants, or IWPPs. Sqwec IWPP is a second, and with a project value of $1.831 billion, it is also currently the third largest IWPP project in the world. Sqwec Water and Electricity Company, or Sqwec, is to undertake the development and operation of Sqwec IWPP on a build, own and operate basis. The shareholders of the project company are Public Investors Fund, 32%, Saudi Electricity Company, 8%, Sqwec International Water and Electricity Company, 60%. The head office of Sqwec is located at a site along with consultant and EPC contractor's office. The project company has the responsibility to oversee the design, erection and commissioning of the IWPP based on the turnkey EPC contract. The Sqwec 2 IWPP is being constructed on the Red Sea coast at Sqwec, 140 kilometers north of Jizan, in the Kingdom of Saudi Arabia, with a project construction period of 42 months. The power and the desalination plant will be ready by November 2010 and produce 850 megawatts of net power generation and 212,000 megacubic desalinated water per day. The plant will supply water and power to the cities of Hsia and Jizan areas, which is a region that has been subject to water and power shortages. The site is located 140 kilometers north of Jizan city and 105 kilometers southwest of Abha hill station city. As of now, most of the completed civil work has been completed. The 1020 megawatt power plant will consist of heavy crude oil fired boiler, 3 steam turbine and 340 megawatt generators. The plant has been configured into 3 groups, each group comprising of a boiler, a steam turbine and a generator. Steam from the boiler will drive the turbine to generate electricity both for the plant house load and for export to the grid sect 850 megawatts via the electrical specialist facility. This is a 380 kilovolt gas insulated switchgear which connects to the grid through overhead lines to Abha East substation and Al Qudmi substation. Engineering and manufacturing of different component and construction has almost completed. Seawater from the pump house will be distributed throughout the plant using glass reinforced pipes. This seawater is used not only for producing potable water, but also for cooling power plant and also as a medium for reducing emissions from the flue gas. The major components of the water island are seawater intake, 1.2 kilometers away from the shoreline, pre-treatment, RO desalination plant, potabilization plant, water storage and outfall. The desalination plant is consisted of 16 RO trains. Each train consists of 2 RO passes, and each pass has its own RO rack, high pressure pump and piping. When in operation, the 16 desalination units will produce 212,000 cubic meters of potable water per day, whereas 4,000 cubic meters will be used for the plant's internal consumption. After mineralization, the water will be stored in 3 water tanks, with sufficient volume to store a 2 days production. The capacity of each tank is 146,600 cubic meters. The heavy fuel oil for the plant Phase 1 SWCC and Arabian Heavy Crude Oil Phase 2 IWPP will be supplied by marine tankers. The tankers will berth to a new unloading platform which is approximately 6 kilometers from the shoreline. The platform is suitable for berthing tankers 20,000 DWT and 100,000 DWP. Berth tankers will be connected to the submarine pipelines by unloading arms located on the platform. Heavy fuel oil required for operation of existing Sqwec Phase 1 plant is currently unloaded using single buoy moorings, suitable for berthing of tankers having the capacity of 20,000 DWT. The SBM system will be dismantled and the existing pipeline will be extended to a new unloading platform. The fuel will be pumped to the storage tanks using tanker pumps. Total storage capacity will be 230,000 tons and it will be sufficient for 45 days of full load operation of the plant. Many challenges are associated with the supervision of the project of this complexity, challenges that spread across a number of continents. Fabrication and manufacturing of the components takes place worldwide before they are delivered and assembled at the site. To avoid any potential impact on erections scheduled on future reliability of the plant, the Sqwec project team have implemented management systems using the internationally recognized guidelines. Recognizing that quality of work is paramount to the success of the project, a comprehensive risk-based quality inspection program has been established. Through scheduled inspections and regular audits, constant vigilance ensures that the quality of work is maintained. In terms of health and safety, the whole workforce has received introduction training. Combined with strict management regime, this has successfully minimized the risks associated with ongoing works. Daily toolbox talks constantly remind the workforce about their responsibilities both to themselves and to their colleagues. Weekly audits and walkdowns regularly seek out and rectify any potential weakness in the safety systems. The effectiveness of this program is shown by the excellent safety record: no fatalities, no lost time accidents. Should there be a major incident such as fire, accident or other emergencies, readiness of the site staff is maintained through regular first aid training and conducting of fire and emergency drills. During construction, regular audits are conducted to monitor the environmental performance of the project according to the specified environmental management plan. Compliance with environmental standards is monitored with respect to soil contamination, air quality, water quality, noise levels and waste management. To reduce noxious emissions further, the power plant will be equipped with one of the most modern flue gas treatment systems available today, known as the flue gas desulfurization system. Most of the particulate content is removed by electrostatic precipitators. The particulates transferred to an ash handling system. The flue gas passes through a flue gas desulfurization plant which uses seawater in scrubbing process. The result emissions are maintained below World Bank requirements. When it is completed, the Sqwec project will be the world's third largest greenfield IWPP, providing a sustainable, efficient and environmentally friendly supply of electricity and water to the Kingdom of Saudi Arabia.